Good afternoon, everyone. Welcome to the EOcafe, where the EO community meet. It's been a busy day. In a meeting with the directors, meeting in Prague, waiting to get some news of that. But here we are in the EOcafe, and I'm very pleased that we're joined by two distinguished guests, Carlo Buontempo, who's director of the Copernicus Climate Change Service, the C3S, at ECMWF, and Richard Englin, who is Deputy Director of the Copernicus Atmosphere Monitoring Service at ECMWF. And we're here to talk about the European State of the Climate report that was published 10 days ago, and which is an annual report, as the name suggests. Now, just a reminder of the rules on the EOcafe. Please keep your microphones off unless I specifically invite you to pose your question. You're very welcome to keep cameras on. We like to see you. We like to have an array of faces in front of us. That's great. And if you've got any questions, I hope you do, then put them into the chat, and then we can see them coming, and I'll pick up the questions. And if we take it, then I'll ask you to join and pose your question. So I think everyone's familiar with the EOcafe now. So the European State of the Climate Report 2021 is the fifth report. It's published by ECMWF, and I've already introduced our guests, but maybe I'll ask them just to say a few words about themselves and their roles within ECMWF. Carlo?
Yeah, thank you, Jeff, and thank you very much for this opportunity to talk about the State of the Climate report. I'm Carlo Buontempo. I'm the Director of the Climate Change Service at ECMWF, and I see my role as a bit of orchestrating all these different components that make the Climate Change Service working. So observation, the analysis, prediction, and projections through a common interface to users. So that's basically my day job.
Okay, Richard?
Yes, thank you, Jeff, and thanks for having us, joining us in this EOcafe. My name is Richard Englin. I'm Deputy Director of the Atmosphere Monitoring Service. So my main role is basically to support the Director of the service, similar to what Carlo said, coordinating all the service elements, making sure everything runs and keeps running smoothly, and we provide the data we need to provide and improve the services as well. Part of that role is also that I'm now coordinating some of the new elements in the second phase of CEMS, which is the emission monitoring, and especially CO2 emission monitoring. But I'm sure we can come back to that later. So thanks again for inviting us.
Yeah, it's a fairly free running discussion, so we can go wherever we want in terms of the subject. But one of the things we started the EOcafe as a way for people to keep in touch during the various lockdowns. It's continued by popular demand, but one of the things we've realized is a lot of new people coming into the picture, and the whole setup in Europe is very complex and hard to understand. So one of the things we've taken on is to try to help a little bit understand the roles of the different organizations. So before we go on to talk about CAMS and C3S, maybe you could just talk a little bit about ECMWF and what ECMWF does and the role that ECMWF plays in Europe, but also I think on a wider stage as well.
Sure. Well, I guess ECMWF has probably the gold medal for the company with the most complex acronym, also because it's changing from language to language. But it stands for European Center for Medium Range Weather Forecast. And in a sense, the clue is in the name. So we were funded with that purpose in mind, improving the weather prediction on this medium range timescale that were beyond the capability of national Met services. And we developed over the year to become a center of excellence, not only in Europe, but really all over the world on weather prediction, especially medium range weather prediction and longer predictions. And a lot of that success sits on the data and the data simulation. So ECMWF processes a huge volume of observation, mostly coming from satellite. I would say something more later about this topic, to make their weather prediction. So that's one of the key ingredients of the success. The other being a good supercomputer to run the integration, and also trying to maintain the group relatively small, but focus, trying to pick the best scientists around, in a sense, in terms of processes, in terms of data simulation. That has been one of the key elements of the success of ECMWF. I would think that's probably in a nutshell. I don't know, Richard, if you want to add something to that, or a different opinion.
I can maybe briefly add. It's interesting I've been at ECMWF for the last 20 years now, and I've really seen the center grow. So building on our expertise in numerical weather prediction, as Carlo explained, which really was at the base, well, it still is at the basis of the organization. As an intergovernmental organization, we really thrive on collaboration with our member states, but also within the organization with staff coming from everywhere, mainly around Europe. But using the expertise and skills we have, we've been growing and looking at other environmental problems in the atmosphere, but also ocean, land, all the parts of the Earth system need attention, and that's where we, I think we are excelling and helping society through, for instance, the Copernicus service, where we work with the European Commission to coordinate these efforts and to make sure we monitor the Earth as we should monitor it.
Jeff, I think you're muted.
I muted you to cut out some background noise. Always try to remember to unmute. You have, I think, 35 members, but there's a difference between a full member and a cooperating member. Is that just to do with fees, or is there more to it than that?
I'll have to dig. There is a difference indeed. So it's partly the contribution the members or collaborating states pay, and the involvement they have in especially decision making, etc. We try to be as inclusive as possible. So that's why we have also these collaborating states, and they can actually become a full member at some point, if they want to do so. So we have been expanding. We started with a much smaller number of countries, but we have been growing and growing. And then having the collaborative states is one way of enabling this growth.
Yeah.
And maybe something to add to that is that actually now the member, although we are called the European Centre, actually our member go beyond what is typically recognized as Europe. So we have a member from the Middle East, from North Africa, and further afield.
I was going to go and observe that you're not an EU body, which is probably why the UK has not got got upset about ECMWF staying in the UK. But it has had an impact on your operations because you've moved the Copernicus activities to Bonn. You've opened an cloud processing in Italy. Has it had more impact on your operations? This sort of spreading of the locations?
Well, I guess it's going from a single site organization to an organization that now has 3 sites, because our supercomputer sits in Bologna nowadays, and as you said, a lot of our mostly our European based operational, those related to the European funding, has been running from Bonn. So yes, we have a variety of sites, and going from 1 site to 3 sites has logistic implication and a change a bit of culture that we are managing. I think so far the benefit of this new.
I've lost sound. Is anyone else?
Yeah, I lost Carlo as well.
Carlo.
Oh, sorry. I think for some reason I got muted midway through my.
You're back. You're back.
Yeah. Well, I don't know where you lost me, but I was sort of saying, you know, the benefit of going from one single site or organization to a multiple site organization, in our experience, far outweighed the challenges. Nonetheless, there are challenges and logistical challenges in this transformation.
So that's been one of the impacts. You've got heavily involved in Copernicus, and we'll come on to the report in a minute. How important is Copernicus to ECMWF now?
Well, I think it's a very important program in many respects. It's important numerically, so there are a number of people working for the two services that have been entrusted to ECMWF by the European Commission, so CEMS and C3S, but also involved in the activities in support of the Emergency Management Service that is run by the JRC. So there is that element. There is also an element of leveraging the expertise and the knowledge that we have acquired over the years in numerical weather prediction in this new and emerging field of climate services. And I'm talking about C3S specifically. I think Richard may articulate further on the CAM side, but for C3S, there is certainly this value that goes in both directions. On the one hand, the expanding base of users beyond the weather prediction, and on the other, ensuring that this service culture that is so much entrenched and is so much of a characteristic of weather prediction can actually benefit also longer timescale and different timescales. Mm-hmm.
Mm-hmm. Okay, so maybe we'll come back to CAMS and C3S in the process of discussing the report, but you've just released it so about 10 days ago. I believe it's the 5th one in the series. What are the key findings? Tell us what are the key things that come out of this.
Yeah, I mean, the key findings are some of them are not particularly surprising. So if you look at the greenhouse gases concentration going up, both CO2 and methane have gone up in 2021. If you look at the temperature, that has also gone up. So 2021 ran between the 5th and the 7th, depending on the data set you're looking at, and they're all very close together. So we can say confidently that the last 7 years have been the warmest on record globally. If you look at Europe specifically, and the report clearly focusing on Europe, well, we have seen the warmest summer on record in Europe, a full degree above the 1991 to 2020 average. We have seen these large events, flooding events in Western Europe, Germany and Belgium, and being particularly badly hit. We also seen heat waves in the Mediterranean, forest fire, and very high level of sea surface temperature, both in the Baltic and in the southeast of the Mediterranean. So, I mean, these are the things that typically make the headlines. I like also to pick another aspect that is mentioned in the report, and this is this wind drought that has affected some of northwestern countries, so Ireland, the UK, part of Germany, Czech Republic, and the like, where the wind has been below average. And conversely, on the southeast part of the continent, we have seen an increase in wind resources throughout the year. And the reason why I'm keen to mention also this aspect, because I think that one of the important aspects of the report is the fact that climate and climate information and climate data is becoming almost a commodity throughout the societal system. Different sectors rely on this kind of information. And if you look at now how important is to diversify the energy mix in Europe, then understanding better the impact of climate variability and climate trend when those are detectable, then becomes crucial. So I see the report very much as a way of presenting what we know about the climate in a systematic way, in a timely fashion, and as a way of demonstrating the information this can have, the impact this information can have in the different sectors.
Mm-hmm. Okay, Richard, are you?
Yeah, if I can add to that, the one thing I would like to pick out is if we look at the climate, it's an immensely complex system. And what we see in this report, but also having now a series of reports, is how we can place the changes we see also in the natural variability, and really emphasizes the importance of monitoring not just temperature, but all the aspects of the climate system to really understand how we as humans are impacting the climate system, and how we are causing global warming, but how it's affecting different parts of the world in different ways, and also affecting us in different ways from year to year. And I think that that's really critical to a good understanding of what we're doing to the climate system, and really trying to understand the complexities through very careful monitoring. So for me, that is also a key element of the European State of the Climate report.
I mean, in the report, it's based around climate indicators and thematic events. What are these, and what is the difference? What's the message?
Do you want to go first, Carlo?
Well, I mean, indicators are the one. Sure. You want to go first? Sorry.
No, it's okay, Carlo, but you see the connection.
Can you hear me?
Look, Carlo.
Okay. I was saying, well, yeah, I'm here. I can hear you.
Yeah. No.
Can you hear me?
I think you've.
It's a bit broken up.
Richard, do you want to start while I try to figure out how to fix my connection?
Yes. So, sorry. The question was the difference between the indicators and
events. Yeah. So to make the distinction between the climatic indicators and the thematic events.
Yeah. So if you can hear me,
yes.
I may try.
Yeah, we hear you perfectly well. Yeah.
Okay. Very good. So in a sense, the indicator are the one you would expect to see, the temperature, the SSTs, the growing degree days, and so on and so forth. But the events are those events that are particularly significant. So I was making reference before to the flooding in Western Europe. I was also making reference to the heat waves in Europe, and is to go, or the drought in the wind drought. These are all events that have been significant throughout the year. And while we haven't attempted any attribution study as such, we thought those deserved a bit more of an in-depth analysis, because they were so prominent and so significant and affected in so many different ways our lives as Europeans. So, you know, if you look at the damage caused by the flooding in Europe, that was extremely significant. If you look at the heat waves in the Mediterranean, we probably, yet not confirmed, but we probably have hit the absolute record in summer temperature in Europe, with 48.8 degrees recorded in Sicily. So it makes sense to look at those, or at the forest fire in Greece and in Turkey. So looking at those a bit more in depth to understand a bit better the dynamic of those events. So the two go hand in hand. We want to provide continuity on those indicators that have been looked at before, looking at the rise in temperature, the greenhouse gases, the SSTs, the glaciers, because the element or the reference that Richard was making before about the system, you know, looking at the climate system as a whole, not just at the atmosphere or the ocean, is very important. So all these indicators provide that continuity, provide that traceability back to the previous report. But then we go a bit deeper, and we look in a few instances at this event, because those are newsworthy, because those are significant for our life, and because those have had an impact on our activities.
Okay, but there's still a sort of intuitive jump between these exceptional events, which are individual, which are climatic, but making the case that they are change, that they are different from what could have happened in the past, or without any change in greenhouse gases or the sort of direct indicators.
No, absolutely, and this is part of what is called, climate change attribution in a sense. So trying to understand how the likelihood of occurrence of a specific kind of event has changed because of climate change. In the report, we fall short of an attribution, but we provide context to those events that is important to characterize them fully. And while it's important, in my opinion, and there is a strong pressure from our member state to develop and operationalize an attribution function, it's also true that the Climate Change Service is not just about climate change, and what society needs related to climate is also about having this understanding of the importance of climate variability, as Richard was saying before. So even in the absence of, I would argue, even in the absence of climate change, and that's definitely not the case at the moment, but even in the absence of climate change, it would be still very useful to have a systematic analysis of the event we have seen and a full characterization of the dynamic and the mechanism that led to their occurrence.
Yeah. And I mean, this touches also on a fairly difficult subject, in that the balance between science and communication, because you're wanting to have the good science, which is making the case and making the attribution for the problem, or showing that there is a link there based on science, and the means of communicating this to the general public, who don't understand the difference between a few milligram change in whatever parameter, but do understand that there are massive floods that have hit their lives. But is this due to the few milligram change, etc.? So you've really got to achieve a balance there. And how do you approach that?
Well, I think part of the approach, well, clearly this is largely a communication exercise. Yeah. So the release of the State of the Climate Report is preceded by a press conference, an embargo press release, and so on and so forth. So there is a lot of work that goes in the preparation of that release. And this is, so there is a strong involvement of our communication teams and our contractor working on communication. But that's, you can see that engagement part as a final part of a journey that starts many months before, and start very much with the engagement with the many organizations, both services that we run at ECMWF, so CAMS and C3S, but also the other Copernicus services, the Emergency Management Service, the Marine Service, the Land Service, and so on. And a community that goes well beyond the Copernicus services and involves national med services, involves other international organizations, the EUMETSAT, ESA, university all over Europe, to draft the initial text, the initial conclusion, put together the figure for the report. And after that initial meeting, there are weeks and months of scrupulous review of everything that is said, so that we can be sure that we are confident about the communication push at the end. So that's one side of the story, to have that traceability and that rigor. The other is really to ensure as much as possible to have full traceability back to the data. So if you look in the report, it's always stated where the data is coming from and how it can be obtained. And more often, we actually make or go in the direction of making the plots available, or regenerate, make the possibility of regenerate the plot interactively on the website as a way of ensuring that traceability. So I guess is a communication effort, but it's a communication effort that is well rooted in science and traceability and rigor.
Yeah, okay. The link to the C3S is fairly evident, in that it's producing data and evidence related to the Climate Change Service. But for CAMS, how does CAMS fit in, Richard? Where does CAMS contribute into this process?
Yes, thanks for that question. So CAMS' main activity is monitoring and forecasting of atmospheric pollution and air quality focused on Europe, but also with a global view. So we have been monitoring atmospheric composition for quite some time now. The first phase of Copernicus was already the last 7 years or so, but before that, we were already doing this in pre-operational activities. So we have data records that are now extending more and more in time on things that are very relevant for the climate system. And greenhouse gas concentrations in the atmosphere are a very obvious example. So here we actually work very closely together with C3S, where C3S ensures a very well validated climate data record based on the satellite observations. And we use the CEMS data, which is close to real-time monitoring, to extend that into the last 1 or 2 years. So if you look at the graphs, for instance, in the report, you can see a solid line for the validated records, and then a dotted line for the extension. But the extension is what provides us the latest information, so we can report actually about the concentrations in 2021, which is important. Another example is the fire emissions, and here we also work together with the Emergency Management Service, who look after fire risk and the extent of fires, while CEMS looks at the actual emissions resulting from fires. And here again, we already have quite a good data record going back some time that we can use to look at specific anomalies we see in the past year compared to this long-term record. So yeah, CEMS really contributes in that way by focusing on specific atmosphere-related variables where we already have a good climate data record to support a report.
Oh, okay, I made a very big sweeping generality at the introduction there to say that it was obvious how C3S contributed. It's probably not really obvious at all, but it's obvious that it should contribute. Carlo, do you want to explain a bit more in that respect? How does C3S work to support this activity or contribute to the activity?
Yeah, well, it was one of the things we promised in our initial contract with the Commission in our first contribution agreement to produce this State of the Climate report on annual basis. So it's, in a sense, it's part of our commitment towards the Commission. But okay, what we do as a contribution on top of coordinating it, I guess goes in a number of directions. One is to take advantage of the reanalysis information we have, and the reanalysis offer this continuous record of meteorological and land surface observation or reconstruction going back now to the 1950s with the back extension, but certainly having a higher quality from the 79 with the beginning of the satellite era. So that's an important element also, because as part of the C3S commitment, we update this reanalysis daily with a delay of just 5 days. So the information there gets to basically near real time. And this allows us to produce the monthly bulletin, to produce the state of the climate, or the variable for the state of the climate. So that's one channel. The other channel is through the activities on the ECVs. So the essential climate variable, and when I mention ECVs, so the GCAS definition of ECVs, I mostly refer to the ECVs derived from satellite observation. And there are a number of activities within C3S to support the extension of the climate data record of those ECVs and generate intermediate climate data records. So update those in as frequently as possible to maintain close to real time as possible. And C3S at the moment provide access to 22 of the 54 GCAS ECVs. So these are constitute the natural basis over which to build the report. And effectively, in our contractual arrangement with the provider of the CDR, so the climate data record for these ECVs, there is a contribution towards the state of the climate. So we use that as a basis. But as I was mentioning before, for the first state of the climate, they were basically most of the input was coming from that. And since then, now we are at the fifth, as you correctly stated before. In this report, actually the contribution go way beyond C3S itself and involves a number of other services, university, with whom we don't necessarily have a contractual link. So there is that certainly that level of coordination and curation that is one of the key ingredient that we offer to the report.
It's an important factor. The development of the network and you say curation. I was just thinking. I mean, the M in ECMWF is medium range, which is what's defined as medium range. 7 to 30 days, something like that. Is that the?
I guess that would go probably in the extended range or into the monthly forecast. I think probably the original goal was probably closer to week 2.
Yeah.
As a target. I don't know if you have a better definition, Richard.
Well, the whole idea behind this is that ECMWF was set up to support the member states, and the member states are responsible for the forecasting in their countries. They clearly focus on the nowcasting, what happens in the next few hours, and the forecasting for the next several days. But we also know that weather is really globally connected. So the more information we have ahead of time, the better it is. So ECMWF was really put together to deliver that to the member states. So in terms of medium range, I think originally it was from day 3 onwards, and we have been pushing this to longer timescales.
Yeah, I should have completed the whole observation rather than sort of asking the intermediate question on what was medium range, because what was striking me was the shift from a relatively short period of time, even if it's medium range, out to the really long periods that are relevant for climate change. And I was thinking about the adaptation and the change in the models and the processes in order to make that shift has been quite dramatic.
Yes, but you can see it in that way. On the other hand, if you look at the statistic of our user, we have on the climate data store, which is the central mechanism to serve data and output to our user. At the moment, we have something just above 130,000 registered users, and those and out of those, slightly more than 70,000 are user of reanalysis, so roughly 50%. And reanalysis, if you want, is the key ingredient so the generation of analysis rather than reanalysis is fundamental to the success of the weather predictions. So the big leap forward in weather prediction has been the data simulation, the variational data simulation, and the ability to generate high quality analysis, so high quality characterization of the climate system anywhere on the planet at a given moment in time. So the extension of that analysis to the reanalysis, so the recreation of those analyses over the historical period using all the observation that were available, even those that were not available at the time when the forecast was made, is a natural extension. And interestingly, if you look at climate services, the key ingredient of almost all climate services that I'm aware of is really the observational record, it's really the reanalysis. If you want to look at the climate projection, yes, you need the climate projection coming from the CMEP or the like, or the Cordex and so on. But you always need an observational baseline to hook your projection to, or to assess the realism of your model. So I was giving a talk, a live talk on Twitter last week, and one of the comments from one of our users was about the usefulness for them. He was someone working in the energy sector. The usefulness for them to have the climate model data alongside in the same place where the satellite information was, where the reanalysis was. So I think that's one of the things that we offer to the mix. And it really builds on our strength as an ECMWF, as a weather prediction center.
Okay. And clearly one of the goals is to improve policies and policy decision making in the light of the predictions. You gave a very good example earlier around the wind and the wind drought that occurred last year. I wasn't aware of that. I was aware there were a lot of problems with generation using wind, and that the figures were way down on what had been expected, and that was in the context of energy security and looking at obviously the price of energy and the impact that's having. But immediately, what you're providing then feeds into policy and decisions relating to the balance, this zero carbon goal, which seems a little bit okay. It's a goal, but goodness knows whether it's a realistic cost goal, or a goal with a realistic price. So that was the link to policy. But I mean, people on the call, we're mainly from companies, but not just, a lot from other sectors as well, dealing with Earth observation, particularly dealing with observations from satellites. You've already given clues to the answers, but what I wanted to ask, how important are satellites for your business?
Well, they're fundamental. It's the right, front and left. It is everywhere. It's our bread and butter. Going back to the reanalysis, it's just inconceivable to have a reanalysis product without satellite data into it. And we are great consumer of an integrator of those satellite information. I just took note of some of the figure. And if you look over the period from 79 to present, I think the amount of observation that have been assimilated by ERA 5 reanalysis sums up to hundreds of billions of observation. That is just extraordinary. So this is one side of the story. The other side of the story goes very much about the need of maintaining an operational analysis of all the aspects of the climate system, because these are becoming fundamental to understand, monitor, and respond to the changing environment. And there are some aspects, and again, I know I cite the reanalysis a lot, but it's really key to our business. But if you look at, for instance, what has happened in the Southern Hemisphere in terms of performances of our model, well, there is basically a step change before and after the satellite era, because basically there were no observation available before the satellite era. So it would be really hard, if not impossible, to have product of similar quality to the one we have now without the satellite information, satellite data we receive. And there is a good, I mean, talking about industry, talking about Europe, there is an interesting figure that I would like to mention, and it's the fact that even just 20 years ago, the fraction of European sensors that were ingested into our system was probably in the order of 20% out of 50 satellites or so that we are using. And nowadays that fraction has gone up to 45%. And I think that's a recognition of the effort that Europe has put in the space sector and in the space technology, and we are benefiting from it directly.
Good to hear. I guess most of that is to do with Copernicus, or the increase is a lot to do with Copernicus. You're also taking data from scientific satellites. Is the commercial data thrown in there? Is industry contributing to your data mix?
We are taking, well, we had, so the answer as always is it depends, right? But there is no, a priori, there is no limit to the data we can ingest, and the more, the merrier. So there have been, for instance, some interesting experiment done during the COVID lockdown period, where we lost all of a sudden a lot of conventional data coming from airplanes, because the airplanes were not flying. then we didn't have that information, which is still important. It's less important in the overall budget than satellite information, but not less is important. And so there were analysis done on the impact that Spire data could provide as an alternative for that. So it's something that we looked into and we keep looking into, and there is no a priori no barrier in using commercial mission as well as those coming from the space agencies. In some cases, a matter of affordability and how we can justify the cost in exchange for an improvement in performances.
Yeah. Okay. I mean, that ultimately comes down to the business model and how who pays and in what form it's paid for.
I can maybe.
Yes, I was going to say.
Because yes, affordability is of course an important aspect, but there we're making progress as well. For instance, through ESA's and also EUMETSAT third-party mission programs, where they facilitate the provision of commercial data for the services to use. So there is work ongoing to make this better, and so we can benefit from more data, which, as Carlo illustrated, it's critical to all the Copernicus services. We have the models to do forecasts, to look into the future, to look at scenarios, but in order to monitor and to initiate the models, observations are absolutely critical. So the more we can use, the better it is, and that includes commercial satellites.
And are there any obvious data gaps? What would you like to have that
yes
have now?
I have a list.
Question,
it's like Christmas, right?
Yeah, I want 1 million meter resolution over 1,000 square kilometers delivered in 5 minutes. Yeah.
Well, it's different from different parts, and probably the easiest to tackle are the gaps in the ECVs, if you want. So really looking at the variable that we can then generate level 4 or level 3, level 4, and distribute to our users. There are some obvious gaps. Two come to mind more easily than other. One is permafrost. So if you look at what was breaking news over the last couple of years, a lot of it had to do with heat waves in the Arctic, fire in the Arctic, and the like, or the temperature extreme in Siberia. And still, we have a relatively poor sampling of the permafrost from satellite, and at best indirect. So that's one area where we would like to do more, and would like to provide more information for. Another area where we would like to improve our coverage and the quality of our product is surface hydrology. So, in a sense, most of the impact of not all, but many of the impact of climate change are mediated by water in some shape or form, rainfall or otherwise. And for instance, if you look at the river runoff, which is a vital parameter, the observation of river runoff discharge of the river network are, still have a margin of improvement, let's say, and we are not providing those directly as an observational ECVs, but we generate those through integration through models. So that's another area we would like to improve. Sea surface salinity would be the third, probably, in the list. So there are a few that we are looking into in terms of expanding the provision of ECVs over the next 5 to 10 years, let's say. But these are probably the top, the most important one. And they're important also, although partly, for the evolution that we have in mind of the reanalysis product. So the next reanalysis which will start the integration around 2024 and should become available by 2027, will be a coupled reanalysis with the ocean. So having more information about the upper ocean will be certainly another benefit. But the following reanalysis, we are talking about the 2030. So who knows what's going to happen between now and then. But one of the elements we are working on is the coupling with the land surface. So the characterization, an improvement in the characterization of the land surface will be important for that exercise as well. And I shouldn't say, because really the expert there is Richard, but I would think that would also benefit the effort towards the emission monitoring and emission quantification in the CO2 service.
Mm-hmm.
Yeah, I can follow up on that. So for the atmosphere monitoring service, we only measure a fraction of what we're actually trying to forecast every day in terms of atmospheric pollutants. And it works because the pollutants are connected through the chemistry. But yeah, the more we can measure, the better it is. And some of it is just limited by what we can actually infer from the observations you make with satellites. But there is scope for improvement. But then following up on what Carlo was saying, now we're starting to well, really the next big step for CAMS is looking at emissions and not just atmospheric concentrations, to better understand how we are affecting the atmospheric concentrations of both pollutants and greenhouse gases. And I think here there's a lot of potential for making better or more clever use of, for instance, imaging data. Focusing only on the atmospheric concentration measurements is just not enough, especially because these don't measure emissions, they measure the result of the emissions. So if we can use imaging data to look at emission sources, or as Carlo was saying, look better at the land biosphere, and also the ocean, actually get a better handle on the exchange of CO2, methane, and other pollutants between the land surface and the atmosphere. We could make a big step there, and I think that's where we might not have all the expertise we would like to have, and where there's a lot more expertise already in the industry, and we see some examples of this already happening. So for me, that's really a future way for more collaboration.
Okay. Does if anyone wishes to join the conversation, just put a comment or a question, hopefully a question into the chat, and come in live. I guess we've sort of turned around the subject, but the subject that the question that I guess I really have to ask is can industry play a stronger role in what's going on? Working specifically in terms of C3S or CAMS, where can industry do more on the input side, or maybe on the exploitation side? Both being possible. Any views?
Well, I guess there are the two sides that you mentioned, right? So there is both the upstream, so to speak, and maybe the gaps or the wish list I was asking for. You were asking for can provide some clue on the direction we would like to see, step changes. And I don't think step changes necessarily come from the big space agency, as we have seen, especially now with it's a new satellite mission, the microsatellite and the CubeSat and the like. The possibility of demonstrating new measurement concept, relatively low budget, I think is a reality. So for me, there is a big role that the industry can play in trying to fill some of these gaps, that things that we are not yet fully capable of observing, and that can be demonstrated in proof of concept mission into a relatively inexpensive mission, and then be scaled up, providing an opportunity for this company, but at the same time exploring new territory which will eventually help us solving or bridging those gaps. So that's one element. The other element for me is more on the service expertise, on the service side, because I was mentioning, the report and C3S in general, and the growing base of C3S, I think is just there as an example, or as an indication more than an example, of a very rapidly changing landscape on the use of Earth observation in the context of climate services. And I mean, for instance, we have now a connection with the European Investment Bank. And you normally don't think of investment bank as a recipient of Earth observation or climate change data. And they are becoming very, very active and very interested user in this, also because of this need for good quality climate data within the financial sector. So the landscape is changing rapidly, and this requires also expertise from the industry, requires new actors stepping in and playing a vital role interfacing, the data available to the ultimate user. So in both directions, I think the industry can play a really vital role.
Yeah. Richard, any from the CAMS perspective?
No, I think Carlo captured the most relevant points, and then also adding on what I said earlier about how we can hopefully benefit from the expertise that's available in the industry already, more on the use of imaging data from satellites, where we lack the expertise. So I really hope that we can bring that together. Friends, we have already iterations with the Copernicus Land Service, where I think the industry is already more active than in the Atmosphere and Climate Change Service. So hopefully we can bring these things better together. And yes, developing new instrument concepts, that's of course always an important thing to further develop. It's always a little bit tricky because a lot of what we do is in the public domain and environmental monitoring through environmental agencies, and there's always a bit of resistance to well, bringing industry in there, but I think we should really try to see how we can find ways to actually do that anyway, within the constraints we have and within the framework we have, so we can both support policymakers and make better use of the expertise that is available in the industry. I think that's important. So yeah, we really want to brainstorm together to see how we can make that happen.
Well, that's certainly the sort of message that we like to give as well. And through mechanisms like the EOcafe to get the exchange going, and we've organised quite a lot of meetings in the past between entrusted entities and other public bodies and the industry to try to encourage the dialogue and encourage the thinking of how best to take advantage of the skills that are there and the competencies. So definitely, and we're more than ready to. I say we because I'm meant to be stepping back. I'm not meant to be sort of so much involved, but certainly as Ersk and the companies involved in Ersk are very happy, very keen to have that dialogue. So I see no one else wishes to join in the conversation. It's surprising. What for you is the? I asked you earlier about sort of the key findings from the state of the climate report. What are the surprises? What surprised you sort of over the last 6 months as you prepared the report? Anything that stands out?
Well, I guess something that surprised us, as most of the people observing and has been in the news, is the jump in methane. The jump in methane concentration, I think, wasn't necessarily expected. Is way larger than what we have seen on average in the previous year. So I guess that was one of the surprises. When you have extremes, it's always a surprise in a sense. The new temperature record possibly was a bit of a surprise, because reaching 50 degrees in Europe, we are not quite there. It's 48.8, but not too far. I think is quite iconic as well as one of. It's not surprising in the sense that you expect temperature to go up, so you would expect this kind of extreme to be broken more often. Nevertheless, has somehow an iconic power to it.
Yeah.
And for me, it was, I think, the high variability of things happening in the year. If you look at Europe, with relatively warm early spring, followed by a very cold period, and then suddenly a very hot August, especially in the Mediterranean area, with droughts, wildfires. If you look at the average for the year, it's not that exceptional, but if you look actually at how it varies throughout the year, it was actually quite exceptional in some cases. So that for me stood out, and then to really try to understand that, that's the next step. Also, what Carlo said with the methane, we really, well, I speak on behalf of the service, but also on behalf of the scientific community, we really don't understand it yet. There's different things that affect methane concentrations, and there's things that point to release from wetlands in the tropics. There might be less chemical destruction of methane in the atmosphere, but it's a combination of factors that we really need to understand better. And yeah, the data we generate through our monitoring is key, is a key input to that understanding.
Yeah, and I guess for all of us, the early frost, the early spring, late frost, and the visible signs you've shown on the television of the vineyards and the fruit farms trying to keep their crops at least at a reasonable level at very high cost, and what that will feed through into the future. Stefan, you want to come in?
Yes, a comment and a question. Comment about the investment banks and the financial world starting to be very interested in. Excuse me, just silence my phone, which is ringing right now. So I remember 16 or 17 years ago hearing José Achache, who was then the director of Earth observation at ESA, saying that he believed that at some point in time, climate information, climate indices would become a commodity. Like you have an index for orange juice, you would have an index for temperature or for humidity or for sea level rise or whatever, and this would help banks and financial institutions to basically cover their risk through trading of such indexes. So I find it amusing to see so many years later the financial world and the insurance world becoming really interested in Copernicus data in general and C3S and CAMS data in particular. And indeed, if you look at the USPA market report, the finance and insurance sector is, in the view of the analysts, at least the sector with the highest CAGR, or the highest annual growth rate that they foresee, and I think it's 2 or 3 times bigger than any other sector in terms of development potential over the next few years. My question is to both Richard and Carlo. One of the things that one of the many achievements of these two services has been pioneering the development of use cases. In particular for C3S, the sectorial services. These have enabled, in fact, some industrial participation, although there's still a lot of public research institutes and academic institutions, but still a lot of SMEs and companies have proposed and developed pilots. I see them as pilots. My question is, well, an advice to all the colleagues from industry to really look into the possibility to participate into those calls for ideas and proposals to develop pilots. How do you see the sustainability of those pilots? Because there are pilots, they're presented as kind of service, but how long is that going to last? What happens when the funding possibly from ECMWF, well, from the commission through ECMWF stops? Because some of them are, well, all of them, I believe, but some of them are so highly relevant that you're like, okay, there's a service for water managers. Are you planning at some point to start funding them? Are they going to become services that the end user is going to pay for? What's your view on that?
Maybe I can start from this second one, if not else, because first of all, nice to see you, Stefan. It's a pleasure to hear your question.
Shared pleasure.
Starting from the question on the sectoral information, yes, indeed. Well, at that time I was responsible for that part of the program directly, so I'm very familiar with it. And indeed, we funded a lot of use cases spanning very many different sectors. And as you said, we generated a lot of engagement with SMEs, with different companies and so on. But there was this question of the sustainability. And in a sense, I think there was a reasoning about what was done in Copernicus 1. And this has informed what is the plan for this new phase that has just started. And the reasoning was that the use cases are there to stimulate the market, to show what is possible to be done, but we can't first, and we don't want, as a consequence, to step into the downstream market and become ourselves a provider of services in all these sectors. So I don't think ECMWF is necessarily well put to provide operational services for insurance or agriculture or water management and so on. But at the same time, we felt it was important to have a portfolio of example that, solid example that can stand scrutiny of how things could be done well. So in this new phase, also considering the growing importance of USPA and their role that you mentioned yourself in the use cases, we stepped back a bit in funding use cases, and we decided to put our effort towards basically for what we call operational services. They are still not operational in the sense that we don't want to do the last mile, but exemplar, if you want. So we will support one for energy, one for water, one for agriculture, and one for insurance as exemplar of sector. And this will be maintained in the foreseeable future. So there will be specific indicators for those sectors and until the end of this contribution agreement. For the other sector, it will be more left to the initiatives downstream of us, and will be also supported by the call for the use cases. And we have just seen a call for use cases coming out of USPA very recently, so will be supported by that mechanism in the future. On the first question about the impact on the financial market, I also recall this discussion many years ago about weather derivative at that time, often were referred to. I think somehow there are some similarities, but there are also some differences. So if you look at what the financial sector is looking for now, is mostly reliable data set that they can use to assess the current level of risk. So a good quality data set that they can look into for calculating indicators and at present, but also a standard way to look at the climate change risk in a traceable way. So yeah, there are similarities, but there are also differences there.
Okay. Thanks, Carlo. Thanks, Stefan. Alan Whiteside wants to know about the state of the Alan, just your question. Come on in.
Thanks, Jeff. Yeah, my name's Alan Whiteside. My background is in healthcare in Scotland, and when the UK was able to work in European projects, I was looking at cross-sectoral issues with pharmaceutical pollution, with the food and drink sector and the water sector, and just wondering if there'd been any kind of initiatives or interest in looking at kind of taking that data and going beyond, say, like the interest of digital twins, where we could look at these things in a third-person perspective, of putting it into like a metaverse where we could be first person getting in there and looking at kind of shared issues and shared opportunities that'll have more impact in addressing climate change by looking holistically at the issues.
Carlo?
I'm not sure. I'm not sure we have an initiative, or I'm not aware of any project necessarily step into that arena. I guess the closest one you mentioned is probably Destination Earth and digital twin you were referring to. but you mentioned yourself that probably is one, they fall a bit short of this metaverse and this experience that you were describing. So I think probably that's the closest I would think. I don't know, Richard, if you know.
Yeah,
more.
I'm just trying to think. I agree. Metaverse is probably a little bit too far yet. I mean, what we are trying to do is really connect with different disciplines that are related to the service we provide. So bridge these gaps that currently exist. And for CEMS, of course, the health community is very relevant in terms of air quality and how that impacts health. So we're trying to bridging things and trying to see how we can make data available for use in those different communities. But it's probably not as far as what you are thinking of.
Okay, thanks. I mean, you've mentioned digital twin and destination Earth in there. This is a subject that we want to address within an EOcafe, and we're trying to set up an EOcafe before the summer, where we can understand where destination Earth is, what the status of the program is, what it's doing, and is there any interest from an industrial point of view. So that's that should be taking place before the summer, we hope. Next time we will be talking about the EO Global Action for Space, where we're the action to pick up on EU space diplomacy, and you can see the Destination Earth for program now for the 30th of June. So I hope we see you then. Before we go, to, Carlo and Richard, thank you very much for being with us today. It's been great to talk with you, and it's a subject that we can probably, perhaps we'll come back to next year when the next report's published. In the meantime, is there anything you want to say as a sort of closing remark?
No, but just thank you for the opportunity. Thanks to all the people who have attended the meeting today. It's always a pleasure to talk about these things with you. So look forward to the next opportunity.
Yeah, well, there certainly will be one. Yeah.
Yeah, thank you from me as well. It was really nice to be here, and I'm sure this won't be the last interaction we'll have. So I'm looking forward to further discussions.
I certainly hope it won't be. But there was a request to publicise your monthly newsletters, and people can sign up and subscribe to those. I was expecting to see a link go up in the chat. Maybe it'll appear now, but anybody can sign on to that. From an Earth point of view, 14th, 15th of June, our big event of the year. Everyone's been very, very busy, especially Natasha, working on that. The Expand EO and the Fire Forum, 14th, 15th of June. There will be a physical meeting, but you will be able to join online if you wish. And at that point, I'll close. But as usual, we keep the room open, keep the cafe open. So I saw Stefan raise his hand just as we were closing. So maybe Stefan.
I wasn't. I was clapping. It was a clapping. It wasn't. It wasn't a raised hand. But I agree they look a bit the same. But it was just to thank our speakers of today and ERSC for organizing.
Yeah, thanks. No, it's been good. But now's the point when anybody can just open their microphone and come in and say whatever they want. So it's the even more informal part of the informal EOcafe. So please, anyone who wants to comment, just